All right, tonight what we're going to be learning about are the different types of chemical reactions that you are going to have to know for this class. Once again, a chemical reaction occurs when they're trying to make a more stable arrangement of electrons. That's why these occur. Once again, everything is trying to go towards stability, and chemical reactions are not any different. When you are reading them, once again, the reactants are always what are reacting to produce your products. Okay, so the reactants are always written to the left, products are always written to the right. What are some signs of a chemical change or a chemical reaction? Number one is you'll see a formation of gas. So what does gas mean? So you can see odor or you smell odor, you can't probably see it. Odor or bubbling, or you'll actually see the gas, things like that. A precipitate formation. What is a precipitate? Well, a precipitate is when you have a liquid with another liquid, and what happens is you get this like solid forms. No, it's not like all of a sudden I pour water and Kool-Aid and I get a stapler. What's happening is it just becomes actually cloudy, and if you let it settle, the solid would actually settle to the bottom, and then you would probably see it better. You'd see a change in color, change in temperature, both hot or cold. You see light. This is you have a different taste or smell, so it kind of goes with that, and it is irreversible. What are those 5 types of chemical reactions that you are going to be expected to know? Combustion reactions, synthesis reactions, decomposition, single replacement, or sometimes we'll say displacement. They mean the exact same thing in this class. And then double replacement or displacement. Just to let you know, when we're abbreviating, combustion, we abbreviate as C for this class, synthesis is S, decomp is D. So you can do either SR or SD for this one, and double replacement is DD or DR. Okay, so those are the different options that you're going to do if you want to abbreviate as opposed to writing out those words. All right, first one is combustion. This is the one you're going to want to look for first because a lot of times you'll forget about it. What it is a hydrocarbon. So what is a hydrocarbon? We have an H and a C, okay, reacting with oxygen. And what are the products? They are 100% always carbon dioxide and water. So the hydrocarbon can also have like an alcohol attached to it for this class. So you could have some sort of combination of C and H and then an OH at the end. But you're always going to be reacting with that oxygen. And whenever we give you something like that, you're going to produce carbon dioxide and water 100% of the time. The hard part about combustion reactions is not predicting the products, which you are going to be expected to know, but the hard part about combustion reactions are actually balancing. Just to let you know, the general format is this with these X and Y's. What that means is you can basically plug in any number to those. So if you see like a C1H4 or C2H10, those are all different combustion reactions. So you just fill in a different number for the X and the Y. Synthesis reactions. Synthesis reactions, if you think of a synthesizer, it's where 2 or more things are coming together to make one thing. So like one music composition or whatever. Typically, you'll see A plus B go to AB in this class. Sometimes if we're just expecting you to like identify, you might see like an A plus B plus C goes to an A, B, C. The key about this is that you're only producing one thing. Okay, a lot of times for predicting the products, we're going to have an element plus an element making a compound. For this class, there are some goofy ones that you are going to have to know. There's a few exceptions that you're going to have to know, but typically it's going to be an element plus an element, and you're basically going to squish them together to make a compound. Decomposition is the exact opposite of synthesis, where synthesis is things coming together to make one thing. Decomposition is where you always start with one compound and you break it up into 2 or more compounds. So the general format is AB goes to A plus B, or you could also have ABC goes to A plus BC, or goes to A plus B plus C, or some other combination. But the key for the decomposition, especially with identifying, is that you start with one thing. So decomposition reactions are easy to identify because you are just going to be looking for one thing as one of your reactants. Typically, they will just break apart into your different elements, other than those few exceptions that we'll get to in a different set of notes. Single replacement reactions is where an element or an atom by itself tries to replace the element that's involved in a compound. So you have a general format of A kicking out, let's say, B. Depending on whether A is a metal or a nonmetal, if A is a metal, it will kick out B. If A is a nonmetal, it will kick out X. Okay, so it depends. It'll kick out its like. We will be going into this more often or more thoroughly later. when we actually try to predict the products, but this is just a general, how do you identify them? So predicting products, what you're going to be given is an element plus a compound, and your products will always be an element plus a compound, okay? Double replacement this is not the right formula for a double replacement. Let's get rid of that. It's where an element from one replaces the element of a second, and they're both compounds. So what it would be is AX plus BY goes to, we're going to swap those guys, so BX plus AY. Okay, so how do you identify it? It's always going to be a compound plus a compound goes to a compound plus a compound. So let's just try to identify them based off of these 5 different types of reactions. So the first one I'm going to do is I'm going to look for that combustion reaction. It's very, very easy to identify when you're given the products because you're just going to be looking for carbon dioxide and water. So this would be my combustion reaction. Highly recommend that you look for that one first. Okay, so you've got a combustion reaction. If you didn't have this product, you could still identify this as a combustion because you have a hydrocarbon and then plus an oxygen. All right, now that we've identified our combustion, we'll go back and try to identify all the other ones. Personally, I think decompositions are the easiest to identify because you're looking for something all by itself as a reactant. This is the only one that's all by itself as a reactant, so it's going to decompose. How I remember a decomposition reaction is, yes, it's the exact opposite of a synthesis reaction, but if you think of an animal decomposing on the side of the road, you start with one thing and then it breaks apart into smaller things. So we've got a decomposition. All right, now I'm ready to identify these other guys. This is an element plus an element, and if I look at it, this is the only one where I make one product. Which one only makes one product? Well, it's where you have that synthesis reaction. So this would be a synthesis reaction. All right, now I'm between single and double replacement. This is an element by itself. This is a compound. This is an element, and this is a compound. If I were to look at this, I notice that that Cl, which is the element, kicked out that I. Okay, why does it do that? Because Cl wants to, everybody wants to be, every element by itself wants to be a part of a compound. Why is that? Because at that time they have an octet. When they're by themselves, they don't have that octet. So what they want to do is they want to kick out and they want to be a part of a compound if at all possible. We'll go into when that occurs more often later and more into depth. But right now, if I look at this, Cl kicks out the element of I and it combines with Mg. So now it's super happy and I is by itself. This would be a classic single replacement reaction. I have an element with a compound and I form an element with another compound. The last one is we've got a compound plus a compound, and we form a compound plus a compound. If I look at this, I consider them like wife swap. So I've got the Na, and it's going to switch with the CD. It's from a TV show where in the past they would have two couples that are extremely different from one another, and the wives would actually swap. So the one wife would live with the husband of the other couple, and then the other wife would live with the other husband of the couple. This is the exact same thing that happened. So Na now goes where CD was, and CD goes where Na was. So that's where we get this thing, and this would be a double replacement reaction. All right, hopefully you can kind of identify synthesis, single, double, replacement, combustion, and decomposition reactions just by looking at the general formats as of right now. Have a great evening.